The cone, much like the pyramid, again, has that apex or that point to it. You can kind of see in its shape how it is decreasing, shrinking as the height expands. And because of that, that same relationship of 1/3 takes place. If you were to take this volume and pour it inside of the matching cylinder with the same cylindrical base, circle base, and the same height, you would fill exactly 1/3 of that space. If you poured it in there again, you would fill another third to be at 2/3. And if you did it again, you would fill it completely. And so that relationship exists one more time, where it is exactly that 1/3 of the cylinder that would enclose it, which I think again is very kind of cool, that it is that clean and crisp relationship of 1/3. So another way to think about it, and we don't do much with this, but using that limit argument, also this is another way to kind of approach that. It's the reducing of those rings on all the way up until it's done. And it uses kind of that argument of a limit that is a higher level mathematics concept at this stage. So doing one like this is just quite simple. It's 1/3 BH again, where B is a circle, which is pi r squared, and h is the height from the base, perpendicular to the base, to the apex there, which is 8. And when we put these numbers in, we get 24 pi centimeters cubed. Again, I'll just leave it like this. You could convert that to a decimal if you'd like. In the second example here, the classic trick that we have, we're missing the height, but we have a nice little right triangle. By now, I'm hoping that you know that this is a 12 because of 5, 12, and 13. And now I can just do volume equals 1/3 BH. 1/3, my base is a circle, so it's pi. R was given as 5 squared, that's my base. And my height, I found it to be a 12. And when I multiply all of that stuff together, I get 100 pi centimeters cubed. The final question is to awaken us to some of the other cool tricks of the trade. Notice this was 120. When I split that in half, I get a 60. What that actually means is, ding, 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 a 60, 30, 90 triangle. So this has got to take us back a little bit. This is the long leg, so we would be going to the short leg, which would mean dividing by √3. And when we do that, we would rationalize that out. And when this simplifies, actually, we get 3√3 over 3, and finally it's just √3. So our height is just the square root of 3. Therefore, the volume of a cone is 1/3 BH. 1/3, our base is a circle, pi r squared. All of that is the base, and our height is the square root of 3. This simplifies to 3√3 pi centimeters cubed. And again, that can be turned into a decimal, but not needed to at this stage. That's a nice perfect example of an exact value.